In this video, I wanted to do an example of finding a limit algebraically in the case that we had more than one variable involved, because I missed this one in our live class. Not on purpose, but just we were running low on time. So one of the examples we didn't have time for, limit as h approaches 0 of 4x squared plus 4xh plus h squared. This one is actually quite relevant for the next couple sections, so I think it's worth not skipping. And right off the bat, we can see that we have three terms. We could always use limit law number 3 to break it into three individual parts. So we'd have the limit as h approaches 0 of 4x squared plus the limit as h approaches 0 of 4xh plus the limit as h approaches 0 of h squared. And the question is, well, how do I deal with a limit when the variable within the limit does not match the variable within the input of the limit itself? And basically, the answer is quite simple, is that we treat the variable x squared here as a constant, because here we're concerned about, well, what's the limit as h gets close to 0? But this, we have no h, so essentially we would treat this like a constant value, and the limit of a constant is just that constant. So this limit would just become 4x squared. Essentially nothing would happen because h does not affect this algebraic term in any way at all. Now moving on to the second term, we have the limit as h approaches 0 of 4xh, and that limit law was limit law number 1. But so the limit of 4xh, well, in the same fashion, this one actually has h in it, so it's a little different. But 4x does not depend on h, and that's a multiplier. So we could use limit law number 6 to factor 4x through the limit. And one of the principles that I like to remember is that if it doesn't depend on h and it's multiplied, I can factor it through. We can split up limits normally, and anything not dependent on h can go right through the limit. But h, since h is involved in the boundaries of the limit, we cannot pull that part through. And the last one does depend on h. So by limit law number 2, we could pull the exponent out of that. So this would be the limit as h approaches 0 of h quantity squared. So far we've used law number 1, law number 2, law number 3, and law number 6. But here, basically all that we're left with is the limit as h approaches 0 of h. And remember, once we get it down to just h and it is a match, we can go ahead and plug in 0 by law 0, which would give us, well, 4x squared, the first term. The second term would be 4x times 0, and the third term would be 0 squared. Of course, the last two terms, since they're multiplied by 0, would cancel or go to 0, and so we'd be left with 4x squared, the only remaining portion of this limit. Or we could use the direct substitution rule. Since these are just polynomials, we could directly substitute in h equals 0 into those terms. So the two terms that involve h cancel, and the one that we're left with is 4x squared.